Do you like self-driving cars, Johnny?
No.
Then you will like.
I like gladiator movies.
I like gladiator movies. Then you will like this article by Lily Triadu.
Good.
I'll just call her Lily E from now on, so I don't continue to butcher her name.
I think I saw her in a club. Lily E.
She is the professor of civil engineering and the director of the University of Florida Transportation Institute at the University of Florida. In her article, When Cars and Stoplights Confer, she starts off by describing some of the maybe the ethical or at least uncomfortable issues that were faced and going to be faced when it comes to self-driving cars. And trust me, this is not, just like the internet, it is not going to go away. It's not a whim, I don't believe. It's not just a flash in the pan. You are going to see self-driving cars, and they will be ubiquitous and not too much longer. That's my personal opinion. But there are some issues with them that people are tackling right now. For instance, how about the computer in the car having to make the decision to, I don't know, kill a sidewalk full of kindergartners or kill the driver in an oncoming car, otherwise known as the trolley problem. Been around, ethical problem that's been around for a long time, right?
Right, yes.
And by the way, people have to make that same decision as well. But how does a computer make that decision? How do you pre-program it? Exactly. Yeah. The ethical issues are actually being studied a lot. MIT is looking at this a lot. How do you program a computer essentially who you're going to kill, who you're going to harm? It's an untenable situation. A kid has just run out in front of the car. Do you slam on the brakes knowing that you don't have enough distance and you're going to hit this kid anyway, or do you slam on the brakes and swerve into oncoming traffic knowing that you're going to get in a crash and probably hurt somebody anyway?
Right.
I mean, it's untenable, right? You're going to lose either way.
Yeah.
And how do you program a computer to make that decision?
And how do our brains make that decision in real time in split seconds?
And we have the same problem.
But
except we don't think about it ethically beforehand. We just react.
We just react. We don't say, well, when this happens, I'm going to do that.
You might slam on the brakes. I might swerve. Either one of us is going to end up causing harm.
Yeah, exactly.
Okay.
Wow.
Or something maybe not related to hurting somebody, but just a practical problem. The safest thing, for instance, for autonomous cars to do is to stay as far away from any other car as possible. But if you do that, you're going to cause traffic congestion. You need to, have close tolerances. So all that said, autonomous cars have a lot going for them. They've got faster reflexes. They don't drive drunk or tired or distracted or texting or fiddling with the radio or the DVD or the DVD for your kid in the back or messing around. Stop doing that. Don't make me stop this car. Or anything. And here's the thing. If you can have cars that not only communicate with other self-driving cars, which is already on the books, but communicate with the traffic infrastructure as well, stoplights, for instance, or road sensors, then you have some really cool possibilities. And that's part of what the University of Florida Transportation Institute is looking at. Cars cooperating with infrastructure, not just having their own smarts or communicating with other cars, but communicating with infrastructure. They've created something called the iStreet. It's a testing infrastructure for autonomous vehicles and related technologies at the university. And as Lily E. puts it, as new components such as sensors and other monitoring equipment are installed on roads and highways in and around the university's campus, researchers are able to evaluate a range of advanced technologies. For instance, cars that can talk to other elements of the system, including each other, and can drive themselves on roads equipped with sensors that monitor traffic conditions. So preliminary tests have shown that by doing this, they can reduce driving time, safely reduce driving time, by 16 to 36% per vehicle. So for an individual vehicle, individual driver on an average commute, this may only translate to maybe a minute. But take that hundreds of thousands and multiply by that minute. Well, now you've got hours or days saved in transportation time, which is related to productivity and so on and so forth. So at least initially, they're looking at these modest savings that add up to a whole lot in aggregate, and while not impacting the safety of drivers. And this is all through the cars communicating with infrastructure. Now, we've got to point out that a lot of these things that they're looking at right now are because we operate, or going to be operating, or operate right now in a gray area. There's a mix and this will continue probably for a decade or more, a mix of autonomous vehicles and human-driven vehicles. Once you get to the point, which we will reach, where all vehicles are autonomous, then I think the issues get a little bit more simple. Because now you're not worried about what does the human-driven vehicle going to do. If all vehicles are driven autonomously and communicate with each other, you're going to most likely almost eliminate vehicle-to-vehicle accidents, and then you're just left with trees falling, kids running out in front of the car, stuff like that, which isn't controlled. But it's this gray area right now, I think, which is causing people a lot of consternation.
It's not that different, really, from a factory where you have these robots that are kind of walled off, but they're now beginning to integrate them into the human assembly line as well.
Exactly.
And the issues with that of the robot having to, well, the robot and the human both having to learn the other procedures. I mean, as human beings, the human brain is so incredible. I mean, when you're driving, when you're working, you can put your mind in someone else's mind to kind of see and feel what may be
what they might
happen.
do. What would I do if I was them?
If you hear a ouch, or whatever, you have that empathetic, you empathize with what's happening, and you maybe move a little because you hear it that's close to you. You don't want to get hit too, or whatever. I mean, and will a machine ever be able to do that?
Well, interesting.
I don't know.
Oh, we're running out of time. Okay, interesting. Here's the thought, though. So let's go back to the trolley thing. So the trolley idea, an autonomous car is driving down the road, and a kid runs out and darts out in front of it. What's it going to do? Is it going to hit the kid, or is it going to swerve onto coming? Now, suppose all the cars are autonomous. And when this car sees an emergency situation, it basically broadcasts the situation, and all the cars react at the same time. They stay out of this car. Maybe this oncoming car goes, oh, I have room off to my right. So it swerves to allow this car to come in.
Wow. Within
milliseconds.
Wow. Yeah. That's crazy, Dirk. That's crazy, man.
It's crazy, man.
But you know what?
It's
I
coming.
think it could happen.
It's coming.
All right.